In this lesson, I will be showing you how to navigate RStudio. There are many components in this software, and this will be a simple introduction. As we move through the lessons, I will introduce different components and functions as they are needed. But for now, let's just look at the basic setup. When you open RStudio, you should see this basic layout known as the workspace. Anytime you execute code or add files, it becomes part of this workspace. On the left, you'll see a big window called the console. This green arrow here is where we type lines of code which R will execute. This is the same window you see when you open up the base R software. On the left, you can see some smaller tabbed windows containing lots of information about the current R environment. Environment contains a list of data and objects that we assign through the console. For example, if I enter in a equals 1, we now have a new variable in our environment. Sometimes this environment tab is called the workspace tab. I think it just depends on the version of RStudio that you're using. So the next tab contains history, and it actually lists all of the previous commands I have executed through the console. So you can see most recently, here's a equals 1, the last line I executed. If you double click on a line of code in the history, it will populate the command line in the console, but it will not execute. You still have to press enter for that to happen. For example, if I double click on 5 minus 15, we can now see it at the command line. If I hit enter, it will return the value -10. And we can see that that most recent line of code has been added to the bottom of this list. The next tab is help, and this is very useful for when you're searching for certain packages or functions and you're not exactly sure what the name is. You can just enter a few keywords and look for all the functions that contain those words. Now let's look at the tabs on the bottom small window. First, we have Files, which shows all of the files and folders in the current working directory. We'll talk more about what a working directory is soon. The next tab lists all of the plots that were created with the ability to go back and forth between the plots and export them as different file types. The next tab is Packages and shows us all of the packages that are currently available to us. You can adjust the sizes of these different panes by dragging these dividers back and forth. So there's one to divide the two different columns, and for the row on the right. Now let's open our first script using the white button with the green plus sign. So we can see it up here at the top left, and I'm going to start a new R script. Here we go. So a new pane has appeared and it sits on top of the console. All of our scripts will open as tabs. We can easily go back and forth between them. This new window holds all of our scripts, and it's basically a code editor. It allows us to build code which we can execute in the console line by line by using this run button, or we can run the whole script at once by using this source button. So let me show you how this works. This script is going to be creating two variables, A and B, and also C, which is going to be the summation of the two previous variables. And I'm going to save it real quick. I'm going to just save it as testscript.r. I've already written this before, so I'm just overriding it. So now we have this new script here that we've saved. Anytime it says untitled, it means it has not been saved yet. So I can close it, and I'll close all the tabs actually. And now I'm going to open the last script I just created. So that's how you save and open scripts. So now let's talk about the run and source buttons. I can run each line individually by hitting the run button, and each time I do it, the cursor, this red blinking vertical line, is going to move down the different lines. So I've just submitted all 3 lines, and you can see that they've executed down here in the console. And now if I go to my environment, we can see these 3 different values. Clear the environment, and now I'm going to show you what it looks like when we source the script. You're only going to see one line was entered into the console, and that's source testscript.r. It created all 3 variables for us, so it worked very well. There's some helpful tools for this code editor. If you want to search for a piece of code, just click on the magnifying glass. You can find all the different places where that occurs. And you have the option to replace whatever you're searching for with something else. I want to replace the letter A with E, and I want to replace all. It will tell you that it replaced 2 different occurrences. Now my A has been switched to E. In this lesson, I gave you a brief introduction to the RStudio layout. I suggest you spend a little time becoming familiar with the environment and try using some of the features I have yet to mention. There are a lot of tools in this software, and it will make learning and working with R very easy. In this lesson, we're going to talk about packages. Packages are very important to R. They're collections of functions and data put together by different individuals in the open source community. When you install R in RStudio, a set of basic packages are included. But we often need more specific functionality, and we will be using a few different packages through the course. So to get a list of all R packages currently available, we can use the library function in the console. Now, a quick note about this library function before we talk about the tab, R packages, that opened up for us. When we execute lines of code such as library, we are telling R to look for the library function and execute the function code. Sometimes the function will require us to enter what are called arguments. But in this case, the library function works without any arguments. Now, if you want to see the code of the function, you simply need to enter the function name into the command line with no parentheses. When we do that, the console prints all of the code of that function. And you can see that this function is rather long. Now, a very useful feature of RStudio is called tab completion. Whenever you're writing a script or entering lines into the console, you can press tab when typing a function name. For example, if I start typing the library function and hit tab, it's going to give me a list of all of the functions that contain those letters. If the library function is what I want, I can either hit enter when it's highlighted or just click on it, and then it's going to complete the function name for me. Then, if you start entering the parentheses and hit tab again, it's going to give you a list of all of the arguments you can enter into that function. It also gives you a brief description of what those different arguments do. So when I executed the library function, a tab popped up above the console, and it's giving me a list of all of the R packages that are currently available on my machine. Now, if we want to use any of these packages, we need to make sure they're loaded into our R environment. To get a list of packages that are currently loaded into the environment, we can use the search function. Now, one package we'll be using a lot is the mass package. I'm going to make sure I have it installed on my machine using the install.packages function. So we now have the mass package available on our machine. So to load it into the R environment, I'm going to use the require function and enter the package name of interest as an argument. So I'm going to require the mass package. Now it's good to note that R is case sensitive. So if I do lowercase mass, that package doesn't exist. It's going to give me a warning message saying that there is no package called lowercase mass. Now a lot of this information that I just explained to you is also available in the Packages tab. The Packages tab will show you all of the packages which are currently on your machine, and any packages that have a check mark next to it are loaded into your R environment. You can see here is the mass package with a check mark. If I uncheck it, it's going to unload the mass package. Now we can also install packages in this tab by using the Install Package button. To install packages this way, you just need to type in the package name and hit install. Install dependencies means that if a package requires other packages to work properly, it will make sure that all of them are downloaded and installed. So in this lesson, we talked about packages, and more importantly, how to install and load packages into your R environment. We also talked about the tab completion method, which is very helpful for when you're trying to figure out which arguments to use or which functions to use. In this lesson, I'm going to talk to you about how to assign variables. Variables are different objects that we create in the R environment that we manipulate to find out more information. First off, let me show you some variables that already exist. So for instance, if I enter any number, it will return that number. It recognizes that as a numeric variable. There are other numeric variables, which are characters. So if I type pi, that's going to return pi to the 6th digit, so 3.141593. These are variables that already exist in the R environment, and it's important that we don't override them. For example, I wouldn't want to name pi as something else. I don't want to make pi 2. If you try to have R return variables that don't exist, you'll get error messages, object X not found. We can assign variables two different methods. We can use an equal sign. So if I do x equals 1, we'll assign the number 1 to the object x. The other way to do it is to use a left-facing arrow with a dash. Both ways will do the same thing, but we're going to stick with convention and we're going to be using this operator as our assign operator. So now x is 1, and we can see it in our environment tab. If I assign a few different variables, now we can do math on these different variables that I just created, and we won't get any errors. So if I try to add 1 to a variable that doesn't exist, object W not found, it can't work because it doesn't know what it is. So now the R environment recognizes these variables. These are known as numeric variables, and we'll get to other types of variables soon. But numeric variables can be manipulated with any mathematic operator. Again, I can return any of these. Why do you think we got this error just now when we tried to enter X? It's because I entered capital X, and R is case sensitive. Capital X has no value yet, while the lowercase does. Remember to keep uppercases as uppercase when they need to be, and lowercases as lowercase. Now, we can reassign variables at any time. Currently, x equals 1, but I can assign x to equal y. So now x equals 2, as does y. We can also use the assign notation twice in one line, and R interprets the second one first. I'm going to make x equal 1 again, and then x is going to be assigned y, which is going to be assigned z. Now, I can't really think of an instance where you want to do this, but you never know. I'm sure it exists. So now, x equals 3, y equals 3, and z equals 3. So it interpreted this part first, followed by this part. It's also possible to reverse the assign notation. So if you do a dash followed by a right pointing arrow, we're assigning 15 to x. And now x equals 15. But let's just stick to convention, and we'll always do the left pointing arrow. Another way to assign variables is with the assign function. And this generally takes 2 arguments. So I'm going to give it the name of the variable that I'm assigning and the value that I want to assign it. So let's do 25. And now x equals 25. The reason we use this function is if you're in a for loop and need to assign a different variable at each iteration that's not created yet, you need to use this character string. In this lesson, I gave you an introduction to assigning variables. This is good to get out of the way before we get into anything else. In this lesson, we are going to cover some very basic object types before we get into the real functionality of R. There are 3 very important types which you will work with often, and they are known as numerics, strings, and booleans. We have already discussed numerics. Here's a line. I'm assigning the variable num the value of 10. And this 10 is an integer. It's numeric, so I can do any mathematical operation on it. The next one is a string. So I'm assigning the variable string with the character hello world. We've received this error because hello world was highlighted instead of having the cursor positioned somewhere in the line of code. When I hit run, it tried to run the highlighted part and not the entire line. So now if I type string, it's going to return a character vector, also known as a string. You can use them interchangeably. To define the string, you have to use these quotation marks, and you can use either double quotation or single quotation. And lastly, the Boolean takes on the value of true or false. Numbers and Booleans can be strings as long as they're surrounded by quotes. And a Boolean is a logical data type which can only take on the values of true or false, or you can also specify it as capital T or capital F. Now there's a function that will tell us what data type each object is. So the class function will tell us exactly what each of these are. So all you have to do is enter the variable name as an argument. So class of the num object returns numeric. For the string, it returns character. And for the Boolean, it's going to return logical. So you can use logical and Boolean interchangeably, just as you can string and character. Another similar function is is.numeric, is.character, and is.logical. These functions will return a Boolean object. If I do is.numeric, our num variable, it will return true because it's numeric. If I enter something such as a string into this, it's going to return false. Is.character string, true. What about Boolean? False. Is there a way to convert between these data types? Yes, there is. Similar to is.character, we can actually do as.character. And if I enter num, it's going to return the number 10 surrounded by quotes. So it looks a little different now than when we just return the number. It's no longer numeric, it's now a string. Let me try that again. So when I do as.character Boolean, it returns true in quotes, very similar to how it reacts with the number. Now, what if I try as.numeric on a string? It's actually going to give you an error because it doesn't know how to translate the string into a number. So it returns NA, not available. We can use as.numeric on a Boolean object. So when we do as.numeric on a Boolean that's true and interprets it as the number 1. If you enter false, it returns it as 0. As.logical is another important part of this because I can enter in the number into as.logical. And remember, our number is 10. When I enter this, it's going to return true. So the way it interprets numbers is that any value that equals 0, it will return false. Any other number, it will return true. As.logical -1 returns true because it's not 0. So these can all be very helpful when we start building conditional statements. Now, we often create Booleans when we want to investigate an object. Let's say we want to know if a variable is less than a certain amount. Let's evaluate our number. So I'm going to check to see if it's less than 100. It returns true. Now I can do less than or equal to 100, and it also returns true. And then if I want to see if it's less than 10, it's going to return false because our number is 10. This syntax is asking a question. It wants to know if number is less than 10. And so all these different things that I've been entering in here are logical operators. So if you want to see if the number equals another number, you have to use a double equal sign. So it returns false because the number is 10. And if we use the single equal sign, it actually assigns the variable to equal 12. So that's why we need to use the double equal sign. And lastly, if you want to check if it's not equal, use an exclamation point followed by an equal sign, and that will return true. One more thing, we can also do logical tests on strings as well. Remember, our string equals hello world. I'm actually going to copy this line so I can do less typing. If I do double equal sign here, it will be comparing to see if string equals hello world. And we know it does because we just assigned it. If we change any character in here, hello world, it's going to return false. In this lesson, I gave you an introduction to 3 basic but important data types, and those are the numeric, the character, and the Boolean. In this lesson, I'm going to show you a handful of functions to help you manage your workspace and environment. The first one I want to introduce is getWD. And what this does is it shows you what the current working directory is. Now, the current working directory is the folder that R will write files to and try and load data from. So if you go to your Files tab on the bottom right, you'll see that this is the current working directory. When you type get working directory, it returns a character string, which is the path. I'm going to assign a variable, dir, with this path name. So now anytime I type dir, it's going to return whatever that character string is. If you want to set your working directory to be a different folder, you simply use setwd. And I could type something else in here. And I can't find that folder, so it's not going to be able to do anything with that. But if you were to change your working directory accidentally, you could simply just set it back by using setwd and the dir variable that I created a second ago. Another way to do this is to just go to the session menu and go to set working directory, and you can choose one like this. And it's a pretty simple way to do it, but it's good to know the functions as well. I'm going to create a few variables and show you what we can do with them. X, Y, Z, and T. We can see that our environment is now populated with these 5 different variables that we've created in the lesson so far. If you want to see a list of everything that's in your workspace, use the ls function. And it will return the same list that you see in this environment tab. If you want to delete something from the list, use rm, which stands for remove. And I want to remove X and hit enter. You'll notice that it's now disappearing from our environment. If we do ls, we'll see the same thing. Now, if you want to delete everything in the workspace, you can use the remove function, and you're going to set the argument list to equal ls with more parentheses. So what this is going to do is it's going to return what the list is. That's going to be the list of objects I want to remove. So when I do that, it's going to clear everything. And we now see that our environment is empty. Another much simpler way to do that is to just hit this clear button in the environment tab, this little broom. So if I created a variable again, t is 100, I can clear very simply by doing this, and it will warn you. Get working directory, set working directory, list, and remove are some of the first functions we have come across. A function is simply a separate set of code that will execute when entered into the command line. As mentioned before, some functions take no arguments, while other functions require some arguments to work properly. So what happens if I improperly use a function with no arguments? This is a square root function, sqrt, and it needs a number to be able to calculate what the square root of that is. If I just hit enter with no arguments, it will warn me that that's the case. So I need to enter some number. Now, getting help with functions is easy. If you're not sure what arguments the function might require or want to know more about how it works, we can use the question mark annotation or the help function. I'll show you that right now. So if I use a single question mark before the function name, let's check out remove real quick. It's going to pop up in the help tab an explanation of what that function does and how to use it. And you can see that it'll list the arguments, details. There are almost always examples for different functions. Let's try square root. So square root is part of miscellaneous math functions, and you can see that it also includes ABS, which is absolute value. Now the help function does the same thing. It just searches for the function and returns any information about it. So help and question mark are both the same. If you can't remember the function name, but remember something close to it, you can search through the CRAN network using a double question mark. Let's say we don't know what the remove function is. Enter in a double question mark and something that's sort of close to it, maybe it will be able to find it for us. So it actually returns search results from the RCRAN network, and it will show you all of the different pages of the function descriptions that include that word. And we can see right here, base : rm, that's the function we're looking for. The base : means that it comes from the base package. So if you click on that, it will return you to the same page as when you just typed help rm. Now, since you're beginning to learn R, another helpful function is help.start. And this will send you to a page in the help tab that includes a lot of manuals, references, and different materials about R. So this can be very helpful. I mentioned how in a lot of these function pages, they will show you different examples of how a function works. It's usually at the bottom of the page about the function. If I want to get an example of a function, I use the example function and enter the function I'm interested in as an argument. So I want to see an example of the square root function. And here it tells me that it's going to go through a series of steps. So it requires the stats package, the graphics package. It creates a range of numbers from -9 to 9, and then it's going to plot those numbers against its square root. When I hit return, it returns this plot. So this is their example of showing you how the square root function works. The square root of the absolute value of -9 is 3. We can see it come down to 0 and then go back out to 3. There you go. That's your first plot. We'll cover much more about that later on. So many packages come preloaded with datasets to use as examples. So to get a list of all available datasets that are loaded from the packages that you have installed on your machine, we use the data function. And when you enter that, it opens up a tab in your scripts that shows you all of the different datasets that are in the R environment. So you can see that there are quite a few. We're definitely going to be using a few of these throughout the course. So if you want to load a dataset, you have to enter the dataset name as an argument. One dataset I like to use a lot is the Cars 93 dataset. Let me scroll down and try and find it. If you can't find it by scrolling, hit enter, which will give you a message. In this case, it's in the mass package. And now we can load the data set that I'm interested in. When I go to my environment, you now see a new variable, which is Cars 93. And I've loaded that example data set into my workspace. And one last function I want to show you, which is very helpful when you have a data set loaded into your environment, is the summary function. So when I do summary of the Cars 93 data set, It will actually return information about each of the different variables. And you can see there are a lot of variables in this data set: manufacturer, model, type, price of the car, etc. For each one, it will give you quick descriptive stats about that variable. So what the minimum is, the mean, the max, etc. We're going to cover this more in detail later. I just wanted to show you how to access all of the different data sets that you have loaded in your R environment. A lot of these come with the base package too, and the datasets package. If you don't have the datasets package, you can easily install it by using install.packages. In this lesson, I introduced you to some more functions to help you manage your environment and workspace, and also how to find out more information about functions and example datasets. These will be very helpful as we move through the course.